The problem with running over down.
Well, I had my laptop in my hand. I was kind of aimlessly walking away, so.
Yeah, so I run away with some CrossFit.
I had dinner with Tom Herbert the other night. He told me that you had been office mates pretty early on.
Well, we were in the same neighborhood because we didn't actually share an office. Some point in time, that might have been. Yeah, we were in the same, internet group. That's one.
Yeah. That's many years ago, isn't it?
Yes. Many companies ago too.
I was with Digital when a guy from Sun that was working on NFS, his name was Rusty. I can't remember his last name.
Yeah, he's known as Rusty. I never met him. This was before my time. He was one of the original NFS members.
This would have been 1987 or 88, somewhere around there.
Mm-hmm.
And Rusty, I don't remember his last name, came to Digital and said, here's the NFS code, go ahead and import it to Alteryx. And our engineers looked at it and said, how do we do that? And we sat down and beat it, and we finally did get it done.
But they actually do that with that NFS because I know that later, like Amazon and they have this, they were giving away the RDC code for the NFS code here. I mean, it was a bit more intricate as well. So library, whatever you should say. Even with the native process.
Yeah. Those were interesting days. I was given Yellow Pages to work on. At that time, Yellow Pages had a very, what do I want to say, shady kind of reputation. Because people didn't understand it yet. They didn't understand the notion that one overlay administrative system was controlling all these different things. So.
Okay, guys, this is IPWAVE. We are about to start in a couple of minutes.
Okay, over the agenda website, we can begin. The diehards that have stayed to the end. Awesome. Thank you. Nobody wants to sit in the front row.
It's reserved for the people that read the draft, no?
Well, then you should be up. You said comments, I hope they were based on reading.
That was before the previous meeting. But yeah.
Should we start? Yeah, we are already. Okay, so this is IPWave. This is Carlos Bernardos, and I'm here with Russ Fasley. Can you hear us? Yes, I think so. So, well, this is the typical notice on IPR. So please take a look and pay attention to that if you are not familiar with the IETF rules. And this is the note well, which you should also be familiar at this point of the week. But in any case, please, if you are not, take a look at that and read the documents that are referenced there if you are not familiar. Then before we start, we need to do the classical logistics. So blue sheets are circulating. So please don't forget to sign the blue sheets. Then we need some note takers. So Paul, you are going to be taking notes, right? It would be great if we can have some additional people taking notes. I think it is best if you go to the Etherpad. I will try to also take some notes while sharing on the Etherpad. So I think it's much more easier to collect and also to fix the notes. If you make any comment to the mic, please try to then go to the Etherpad and see if the question that you made and the comment was clearly conveyed or clearly captured in the minutes. Also, you can try to see if your name was correctly taken. So I think it's best if we try to use the Etherpad for this. And we will also need to have some JavaScript because we have some remote attendees, our AB among them. So do we have any volunteer to do the JavaScript?
We can't start till we have one.
Okay, thank you, Russ. So let's start with the working group chairs update. So the status, well, as you know, we are late with our milestones. And the main one is the IPv6 over OCV document. That's, well, we have some iterations since last meeting. We got some reviews addressing the comments from Sixman with the help of Eric. And since then, we moved the document in the process, and we got some reviews from the Internet Area Directorate and the IoT Directorate from Pascal Thubert. And well, we will discuss later how to address those comments in the presentation from Alex and how to move from there. Then we have also the problem statement survey draft that there was some reviews from Sri and Charlie, and the authors will also present how they have been addressing those reviews, and then we will see also what the working group feels about that and whether it's ready for moving forward or not. But just again, a reminder that we really need to close those documents even before considering to consider any potential additional work. So I know that there are some guys that are really interested in doing more things. And as we have discussed with them offline, but it's clear we are not going to be moving because we will not be allowed by SRS anyway to do anything until we close these things. So this is really critical. And then we will be happy to hear and to see whether we can do more things or not. But this is a different discussion that will not take place until we finish these documents. So we have these two documents as we have just discussed. The one on IPv6 over OCV. Then we'll see how these reviews has been considered, and the use cases survey and progress statement. So we'll deal with that into the slots that we have in the agenda. Then this is the agenda. The first part is the administrative, which is what we are going through. Then we have a report on the hackathon that took place in this meeting on the IPWAVE basic protocols from Paul. And then after that, we put that in the agenda first because we believe it may be a useful thing to do this hackathon to progress the work. Then we will go into the IPv6 working group documents, the IPv6 over CV and the survey problem statement use cases document. And this is really important to have the discussion on this to really try to close the pending issues that we may have. So this is the main part of the agenda, and if we allocated 20 minutes for each of them, but if we need more, that's the priority, and we can stay discussing on those more time if required. Then we have additional topics that will be presented type per meeting. One on IPv6 vehicular neighbor discovery by Paul. Then we have on urban air mobility implications from Fred. Some stuff on certificates from William. Some also proposal for mobility management from Paul. So again, these are non-working group topics. So this is just presentation for informational purposes at this point, and there will be no discussion on adoption or anything like that on those documents yet, because they are not in the charter. That is just for discussion for the working group to see if there is interest on those. And then, well, discussion at the end if required. So any comments on the agenda and the agenda bashing? Okay. So let's go to the hackathon part.
Hello, this is Paul Jung from SKKU. So this time, my university and the Sungshin University, two universities in Korea, we participate in hackathon project to show OCB draft and also one proposed neighbor discovery protocol were implemented, and then we show the proof of concept on the basis of the simulation. First of all, we want to make sure OCB protocol is working well. So as a result, OCB, I believe, is a pretty good shape. So it is working. And also, we implemented the proposed neighbor discovery using multi-app DAD, using the DAD optimization. Eric Normark proposed this optimization. So we implemented this multi-app DAD basis vehicular neighbor discovery. So basically, you can see this is the poster for our hackathon. So I will go detail next slide. So this photo shows you can see several people participating in this hackathon project. This figure is the possible vehicular network architecture. So you can see here, bottom, we have the beakers. The beaker can communicate with each other via B2B link. And also, it can talk to RSU via B2I. The most important thing is the RSU wireless link. This RSU1, another adjacent RSU1 has a wireless link is the combined, which means they are using shared the prefix. The purpose is to minimize the update of IP address over vehicle travel along its navigation path. And also, once a vehicle configured, they can talk to each other and also talk to RSU. So if the vehicle 1 has some connectivity with vehicle 3, they can talk to each other via the connected vehicle add-on network, rather than it going to infra network and then forward another infra node and forward. So we take advantage of a vehicular scenario. Because the safety case, the vehicle-to-vehicle communication is important, also efficient. So but certain cases, the vehicle can talk to some cloud server. In that case, V2I should be used. So we clarified that the link can be a multi-link subnet. logically one link. Physically, multiple RSUs are involved. So based on this vehicular link model, the beaker can configure using multi-hop DAD. So RSU and mobility anchor, maybe this is possible, just the scenario, not necessarily the solution. So we try to address. We need to minimize the address configuration overhead. So this, you can see, can configure register, IP address. Eventually, the anchor has also IP address information. So mobility anchor in charge of multiple RSUs. Multiple RSUs also providing connectivity beacons, right? So if they have some address information, they can easily detect the address conflict. So we try to minimize the traditional DAD overhead using this. So for simulation, we have two simulators. The first one is this figure shows the vehicle mobility simulator. It is called SUMO. SUMO means the simulation for urban mobility, so developed by Germany. And secondly, this figure shows the network simulator. It is called OMNet++. So maybe you guys are familiar with the NS203, right? So this is developed by European countries. I think that the Germany is the leading country to develop. This is so we combine two simulators. So mobility of a beaker simulated by SUMO, and the PHY and MAC IP simulation is done OMNet++. Okay, so two simulators are interactively communicate with the message passing. So we have two RSU, two beaker, mobile anchor. So we implemented multi-hop DAD. So this time we implemented beaker structures to enable the vehicular neighbor discovery. So we observed the protocol stack. You can see the wave stack, IEEE 1609. The left stack is a TCP IP stack, and right hand is WSMP, wave short message protocol for safety message exchange. So our IETF has interest in this left-hand side, the PHY, MAC, logical link controller, and Alex proposed the OCB has some sort of a logical link layer controller to provide the Ethernet layer, adaptation layer, right? So we implemented this. So this time we implemented Alex, the OCB draft, and then we showed the proof concept, the OCB and also vehicular neighbor discovery. So we used this simulation stuff. Next time we will implement the Montreal meeting. We implemented a possible mobility management scheme for our IP wave. So this shows the development environment, and this shows the open source project. So we are working using GitHub, so our working group people can download and test the OCB and the neighbor discovery this. So next time we implement the mobility management. Okay, 3.
Sure, so the OCB support is already there in the Linux drivers and all of that, right, in the open source, right?
Yeah, open source.
So
right.
Your implementation is only specific to simulator, or
actually, OCB case, we learning OCB and Ethernet adaptation layer. So we implemented that for our the Alex the draft, right? So current the OMNet++ providing the base. That project doesn't provide that kind.
So to be clear, in the simulator you have implemented this,
right,
not on the standard.
Real
Okay.
Now
I got it. Thanks.
Yeah, real implementation case. Alex, I believe, already implemented. He will report during his presentation, right? Okay, so we take advantage of the simulation real implement. Okay, so this is a YouTube link, so you can click this slide. You can show the simulation stuff. So this is a beaker area network. This is the load network. So two simulators are interconnected and then they work together. So the simulation is the first step. We can approve concept, and then once then we can implement the Linux basis. That is our plan. So hopefully my team, SKQ, we keep working for hackathon project. After the chartering, we develop protocols and then we working simulation first, and then we can implement Linux basis implementation. Okay, that's it. Okay, thank you.
Thank you. So I have one comment or question. So this hackathon experience was mostly focused to evaluate one of your proposals, right? But it's not focused, or was not focused on evaluating the IPv6 over OCV working group document that we have to see and help if the issues that has been brought up to get some experience with that, right? So that's my main question, because I think it's valuable to do hackathon on any proposal, that's for sure. But I think that what we need at the working group at this point is to really help closing the issues with the IPv6 over OCV document. So did you do any experiment or anything related to that?
So our hackathon, part of our hackathon, the OCV is implemented. Without OCV, we cannot implement the neighbor discovery. So that is our point. So we already implemented. So Chris, you can have some comment.
So in this hackathon,
So please state your name.
Chris, SKKU. So in this hackathon, we have implemented the IPv6 running on the OCB mode. So the packet transmitted from the received and transmitted in a vehicle is based on the OCB mode. So basically we, as you know, that there in the OCB mode there's a BSM message. Also now we implemented the IPv6 package, so the IPv6 packet can go through the IPv6 stack. So then the packet, the header, based on the draft in the current working group. So so there's an adaptation layer. So actually, the packet can be translated to the upper layer.
Okay. So and then doing that, did you notice any issue that needs to be brought up to the attention of the working group to be taken while implementing the basic IPv6 or OCV document?
Based on our current implementation, we don't have an issue with that. It works fine.
Okay, that's useful feedback.
Okay, thank you.
Srikandavelli, clarifying question again. So in your whatever you developed, are you using a real radio? Are you using 802.11 OCB or the radio, or is it there's no radio in the picture?
There's a radio.
There's radio?
They are providing radio, so they are providing.
You mean the physical radio or just simulation radio? Actually, it's in the simulator. There's a physical model for that radio.
Okay. So that's again a simulation, but it's not a real radio. Okay.
But free, realistic, radio model. So we can trust. So probably we move on. So next,
Okay.
Alex.
Thank you.
Okay,
Alex?
thank you.
Thank you. Hello. My name is Alexandre Petrescu. I speak now, and my co-authors are Nabil Benamar, Jérôme Hari, John Lee, and Thierry Ernst. I am going to present advancement of transmission of IPv6 packets over IEEE 802.11 networks in mode outside the context of a basic service set. I have a couple of slides, two couples of slides. Since last IETF, the versions are from 31 to 34. There was much editorial changes I will present in the next slides. I take this opportunity to also add 3 other points here. I presented this draft also to the ITU collaboration on ITS standards group, which is based in Geneva. They had an invitation pending to us, and I presented this draft and its advancement to them. Second is that we demonstrated again IPv6 running on 802.11 OCB in a particular context, which is the vehicle-to-vehicle communications that uses 3 cars. Well, V2V is a paradigm, but there are 3 cars, so it's not V2V2V, but it's 2 times V2V. There is a subnet between front car and middle car, and another subnet between middle car and rear car. 2 distinct subnets. On each of them, we run IPv6 over OCB. It has been trialed and demonstrated several times since December. We have filmed. We have shown to several high-profile attendees, and we will show it again during 2019 and probably beyond. Now, also this draft, IPv6 over 802.11 OCB, is also considered at ETSI, which is a European Standards Development Organization that developed a new work item there, and potentially a new group, which is called, the paper that we write right now is called IPv6 based V2X communications. And in it, I'm going to describe soon something about this IPv6 over OCB. So this draft, if it is progressed, it is going to be used at least at ETSI. Also ISO TC204, but that is another activity that I'm not talking here right now. So these are the changes overall since last IETF. Now let me please take this, what happened, the new versions from 31 to 34. They are all on these slides in reverse time order. I start with 34. We updated a reference to a draft that has now become VG item, which is a multicast issue, multicast problems for 802.11. It's now working group item, so it's simple reference update. In 33, some substitution of movement detection for handover behavior in introductory text, removed a redundant phrase referring to security consideration sections. We removed the phrase about link forming mechanisms, since IP is not very much concerned about how the layer 2 links are formed. So we removed that phrase. It's more confusing than clarifying. Removed several phrases about OUI, TXT, and MAC presence in IPv6 addresses, since recently at IETF we consider that IPv6 addresses have interface IDs that do not depend on MAC addresses, neither on OUI. So privacy aspects could be respected, and this is well-known information. But we have clarified an example into which there exist privacy risks of company IDs being present in MAC addresses in public roads. Okay, so basically, if you go now on many public roads and you listen to roadside units, you would notice MAC addresses and company ID present in these MAC addresses. So that could be considered as a privacy risk. Clarified that ND must be used over 802.11 OCB, which is a good thing, because in practice we notice that ND works well over 802.11 OCB. And some beautification of text. We moved the pseudonym section from main section to end of security consideration and clarify the word concurrently. Capitalize the should word about Wi-Fi multicast problems and refer to more recent ID on topic, which is this one. Okay. Now on version 32, significantly shortened the relevant ND over OCB paragraph. And now, after many discussions and many reviews about ND, the paragraph just states that ND is used over 802.11 OCB without detailing. Okay, so this is a clarification that appears here very simply, but it is the result of very much discussion, especially with participants from the 6-man working group that are the experts in this field. In version 31, an earlier review suggested a section titled pseudonym handling without suggesting the text. So then somebody else proposed to fill in that section and provided the text, a specialist in pseudonyms. And we removed the main note phrase about possibility of having other prefix than the link local on the link between cars. Now it is possible to put other prefixes than just the link local prefixes. Initially, we said that probably we may not use any other prefix than the link local prefix. But now the text is written such that it is possible to put some other than link local. That means ULA or global prefix between cars. We shortened and improved the paragraph about mobile IPv6. Mobile IPv6 was there since the beginning, then it got removed, then added it back, but it was too long, so now it is shortened and it is improved. Mobile IPv6 is a great protocol used for mobility in IP, and it is a very good candidate for use for cars, especially if we consider its network mobility extensions. So now in our draft, we have a short paragraph saying that mobile IPv6 is possible, and how, well, 802.11 OCB being a 802.11 link, which means wireless links, there may be need of some optimization, some improvements on neighbor discovery. And DNA is such a protocol for connecting a car to the roadside unit, DNA dynamic network attachment, which improves on some parameters of ND. So we added this reference to DNA v6 together, but we don't go in detail. Yeah.
Yeah, sure. So Alex, I thought DNA v6 it never took off, right? It's practically dead. The document was withdrawn. So why refer to that? Am I missing something or am I forgetting?
Okay, well, I learned it's dead. I learned now it is dead.
Wow.
I thought it's an RFC with a standard on the standard track. DNA
v6? No, Suresh will jump in. Yeah. Yeah, that's what
it's an RFC. There's like some variations of it like being implemented, not exactly as is, right? But yeah, it's an RFC. It's 6059, and there's like I think Google and Apple have some variations of it in implementation, not exactly as is.
Okay, then. Yeah, I missed it.
Yeah, I mean, it's this separate thing. It would be useful to capture what's actually been implemented because it's subsets, variants of that stuff that's out there. But I think it's the best thing we have to refer to this in RFC, saying you should do something like this, right? Even if it's not exactly.
Yeah, that's how the text is right now, Eric. So it pretty much says like something like this should be used, and not exactly that. So it's very, very exemplary text in there. And I think it's a good point you brought up. Like maybe we need to sit down and probably do a BIS version of it. I just didn't have the bandwidth to do it right now, but we can talk about it after.
Okay, so that's clarification about mobile IPv6 and DNA v6, and improved a little bit the text, ND text about ND retransmissions with relationship to packet loss. And again, some aesthetics improvements. Change the title of an appendix from EPD to protocol layering. Well, EPD was suggested earlier by a IEEE expert standing for, well, I forgot EPD, packet discriminator, and we moved it to protocol layering because that section just shows layers of protocols. So protocol layering was a better title for the section, and improve the aspects introduced by OCB appendix with a few phrases about the channel use and references to. Okay, that's OCB. An important aspect of OCB is that it uses channels that are particular to them. Okay, at 5.9 gigahertz, and we added references to some relevant documents.
Alex,
These are the
question from Jabber.
Yep.
On the previous slide, which Etsy group is making the normative reference to our work?
Yeah.
Pascal Tuber, it's called IP6.
Well, I don't think it's IP6. Well, IP6 is a group at Etsy, but it's not that one. Yep. IP6 is a great group at Etsy, but it is not that one where we
I've
propose
seen the
this.
document being discussed there, so I thought, okay.
Maybe it's a new group.
No, there is only IP6.
Is IP6 specializing in V2X and vehicular?
It has documents for IPv6 over anything. So that was the next logical document to publish in IP6.
Yeah, well,
So that's Latif Ladid, etc., right? I mean, that's
yes,
where it is. So
but
that's
he's
IP6.
specialist in starting new groups, so that could
No.
be.
This is being discussed on IP6.
So
at
is
least.
it
Okay.
in the TC on ITS?
Yes, it is a TC ITS, Intelligent Transportation System. So, yeah, so this is a something that should be clarified, and we will pursue as this draft is pursued at IETF.
Thank you.
Yep. So that's about the modifications to the draft up until February. Now, in February, something new happened, but we received a review from for 2 internet directorates. And this review has many comments and questions inside. Many of them are clarifications that could be very easy to fix. Some of them are more delicate, that require some discussion. For example, the first one is questioning the Ethernet adaptation layer. The question from this review is whether an Ethernet adaptation layer is that we describe in this draft, is it different than AP bridging? Is this any different than an access point that bridges between its Ethernet interface to Wi-Fi interface? The answer is yes, it is different in that our EAL, Ethernet adaptation layer, does not bridge between 2 different interfaces. It links a lower layer to an upper layer. And it runs on a machine that has only one interface, physical, and no virtual interface. So there is no any form of bridging in the traditional sense of IETF seeing bridging. And is this, again, the question, is this different than an access point bridging between Ethernet to Wi-Fi? No, it's not different. It bridges between layers. So it's a game of words, but it is different, not different at the same time. So with this explanation, I hope we can keep the text as it is right now. I hope it fits the requester and the review. The second question, which is a little bit harder, and it may take time to discuss, knowing that a discussion is an exchange of messages and not a one-way discussion. It's not a discussion. So the review suggests the use of 6LoWPAN and 6Low.
No.
And excuse me?
No, it does not.
No. Okay, so it does not. Okay, so I disagree because the link is not 802.15.04, so my disagreement is not. Okay, so it does not suggest the use of 6LoWPAN and 6Low. Okay, it's good. So I understand
didn't say
it
that
wrongly.
either. Pascal Tuber here. So I made that review, so maybe I can tell you what it says.
Yep.
So I was suggesting to consider what we call 6LoWPAN ND, which is not the 6LoWPAN header compression, I guess, that you're talking about, which was specific to 15.4. 6LoWPAN ND now evolved into 6Low neighbor discovery, which is RFC 8505. And what I was suggesting to you is to consider the methods that are explained in RFC 8505, which are designed for wireless operation and more adapted to the problem that you have here than the traditional methods that you find in RFC 4861-62, because those were designed for transit links, which is exactly not what you have here.
It's okay. It's a good suggestion. I take it into account. We take it. Is it appropriate? I mean, is it implemented? What does low on 6 low mean? Is it low power? Cars don't have low power, have big power. So these are questions. So I hear the comment. I'm not opposed to adding some reference saying that some 6 low ND over Wi-Fi over wireless could be appropriate, but no more than that, I think.
Okay, so you're saying let's use something which is not appropriate and let's not explain how you can do the appropriate thing. Okay, that's your decision.
Pascal, so there's two things, right? So one of them is like, it's not optimized is one thing, but do you have any issues like considering whether this will work or not, right? Because there's like a bunch of implementations out there of this, right? So I think if you can probably bring up a few of the things, I think the better way for doing this, like in my head, right, at least document what are the shortcomings of using the classic ND in there, and then leave it up to a future version to do the more optimized one. Does that make sense to you?
Yes, that's pretty much how I worded my review. So I ask specific questions like, what do you expect from duplicate address detection in that space if you use 4861 versus if you use 8505? I mean, we have scoped what you can expect from that. And so by having this registration between the two peers, then they can agree that they can use a particular link local address between those peers without any risk of a collision with a third party, so which is designed for a network like that, as opposed to the expectation you have on traditional DAD, which is I DAD once and forever, and I will never get a duplication as long as I stay on this link, which is exactly not what you're doing on a network like this.
Okay.
So I documented
Pascal,
that in my review.
personally for me, right, not with the AD hat on, what I would like is probably if you can help Alex with some text on the shortcomings and say, this is left for future work, right? Because right now this is 802.11 OCB, and then you just say, okay, this is what we're doing right now, and put in some kind of grab bag of issues to look at later, probably in the next version of the document or a different document. And I think that would be both expedient and also respectful of the current implementations. Okay, cool.
Yes, okay. So just pointing out that there are things which work very well when you have an experiment with 3 devices. And when you throw them at the internet, it might be different.
Sure, I think in general, I think we should keep the ND discussion out of this. I think leave it to, refer to the base, ND specs and not go with too aggressive on whether to go with 6LoWPAN, whatever those optimizations, right? I think this operating environment is different. We need to properly, write a proper spec and do that. So
Okay.
I agree with you. I think we don't have to be too aggressive and say that, let's use 6LoWPAN ND or something. Just let's say classic ND, but with the consideration that it is not optimized, it will not work in the way it is expected to work, right? So just leave it in those lines.
Okay,
That would be mine.
Thanks.
Okay, thank you.
Okay. Okay, Chris, SKKU, just for our information. So we have in our hackathon project, we have implemented a minimum size of ND, so which is based on the some concept in the 6LoWPAN, which is suggested by a person last time. So yeah, just for your information. Thank you.
Okay, I think we have some good next steps here. Some of them is in my
So was it Chris? Can you send a note to what are the things you implemented in the hackathon for this? Specifically what from 6LoWND? That would be really good if you can send a note to the list or even at least to me.
So I'm going to present in the following.
Okay.
There is a draft related to this ND, also related to what we have implemented. Yeah, thank you.
Dorothy Stanley. So I think with the 6LoWPAN work, we need to separate out the 15.4 components from with changes to neighbor discovery IPv6 that have been optimized separately that could be really used on any network. I agree with you here that if the implication was the application was only to 15.4, that's not where we are. It's not relevant. So if, from that point of view, the question is, given neighbor discovery, we have a baseline, which is the baseline, well-defined, understood neighbor discovery. Can that be optimized in any way? And what's in the document now is the baseline. So given that we want to get the draft out quickly, we want to, it seems to me fine to go with the current baseline, a future work project of understanding there may be optimizations that can be applied to the extent that between now and the publication of the document, we have a better understanding of that based on the hackathon work. Potentially we can incorporate some of that, but this sounds like a great area for future work.
Yeah, I agree.
So this is Carlos. So if I got the discussion, the consensus well, the idea is that we keep the documenting the baseline, but we also document the shortcomings. We mention the shortcomings that may be in place by using the baseline ND, but we leave those potential enhancements or mitigation of those shortcomings for different work, not to be included in this document. That's correct?
It was a long phrase, but yeah, well, you're
yeah,
a chair,
sounds good to
so
me,
you'll
Carlos.
follow
I
the
think
directions.
that's what I heard too, like from everybody who spoke up. So
Okay, Chris, SKKU. So I agree with the previous the questioner. So definitely we can utilize some the operations in the 6LoWPAN. Yeah, thank you.
So then, Alex and Pascal, before you leave, sorry. So I would like to ask you both, Alex, to respond to the review that Alex posted, because I think that's yet to be done, to respond on the mailing list.
I've not seen it. I'm sorry if it was posted. Oh.
No. I think that's why I'm asking to do it, because I haven't seen that.
No. So I will respond to the review publicly and to you in
And CC me, right?
Yeah. And we try to close all the comments by saying we are doing this, or we believe that this will be done. However,
I can produce a little bit of text based on what Suraj said, which is my understanding was explain shortcomings of what we get today if we just stick to the baseline, and probably put a link on 6Low on wireless ND basically, which was done at 6Low, not 6LoWPAN, and which is not at all 15.4 specific.
Okay, so that's
Dorothy said.
Okay, that will be great, because then once we have done that, we can keep on progressing the document to next steps. But before doing that, we need that new revision and that comments posted to the mailing list. Okay. So just
Yeah, I would start by posting that review. He will suggest some text. Yeah.
And then when we have the revision, we will pick it up from there.
Yeah.
Okay. Thank you.
Sorry, I need to rush to the airport.
Yeah.
Thank you, Pascal.
Yeah, well, I had the last slide, but this is my last slide. I would like to make an observation. At several instances, for example, in the ND discussion, we turned in circles. That means we modify back and forth the same thing without any actual improvement, and worse, without any relation to implementation. We discuss things that don't get implemented, and what's implemented does not get reflected in the text. This is an aspect that is not very good for standardization activity. And I would like to ask to please progress the draft through IESG and publication. We have it running. when I present the demonstration, I'm talking many things, many acronyms, and I would like to really say, this is IPv6 over OCB RFC that is implemented, and it is used between these great cars. There are many other great technologies there, but I would also like to say there is an RFC that is implemented and is put there.
Okay, Alex, wait a minute.
So, Alex, I hear what you're saying, right? But the thing is, like, you know, there's like a lot of people who question like how specific things were done in the implementation, and there's like no response, right? And that's why things are taking a bit longer. They say, okay, like how did this NS message work? And there was no response from an implementer. Like Russ and Carlos sent out messages asking for specific input from implementations, and they didn't get a response, right? So if there's implementations, the implementers need to speak up, like, and if you know of them, like, you know, get them to speak up, because a lot of the questions are like probably simple misunderstandings that can be clarified by people explaining what they did and how they made it work, right? Because that was like, you know, what I've seen as AD, seeing like holding the stuff back, right? Like, so we have like a lot of revisions of the draft, but there's like some questions that were not answered, right? And so it could be, I don't think everything requires text in the draft. If somebody clarifies how they've done it, it may or may not like, require like a sentence in the draft explaining how it was done, right? So, but the thing is, like, an IETF RFC is not just for like, you know, this group, right? Like, you know, we need to make sure that like the rest of the IETF understands this too. And that's why I don't think we can say like, hey, like, you know, have an implementation, we like, you know, there's like, you know, 4 implementations, we decide to make it work. That's not going to cut it at the IETF level. Okay, so that's something I'm just telling you up front, right? Like, so to set the expectations properly, because if a SecDir guy could like, or girl could come and do a review and say like, hey, like, you know, how does this work? And we have to explain. It's not optional that like, you know, the rest of the IETF understands this, right? So that's so I'll just set the expectations straight. Like, once this IoT and INDIR reviews are done, I'm going to send the document forward. Okay, and it's going to go to IETF last call, and you're going to get like all kind of reviews. Like, there's going to be questions about security, there's going to be questions about congestion control, and we need to answer them. So it's not really optional, saying like, hey, it works. It's not like a good justification for like, you know, skipping all those things. Okay, so it takes as long as it takes, because like we are doing this for the internet. Okay.
Okay, makes sense. I will retake the reviews and reply the particular questions that asking how it works, and I will
so
explain.
the bottom line is like we're writing this for somebody who's not been involved in the process, right? So like when I read a document from, let's say, like a security area or something, like I have like no background knowledge of anything. So the only thing I have is a document in front of me and the normative references, right? If it doesn't make sense, I'm going to ask questions, even though it may seem stupid to the person like who wrote the stuff, saying, hey, this is like something we already know. But the question is how clear the document is. So that's why I just want to set the expectations straight for you. Okay. Okay, thanks.
Yeah. So yeah, okay. When we have time, we will discuss a little bit security if you want. Also, that's a weak point, but yeah, security is important, and I can also explain about security if you want. Yeah, now I think I'm at the end of my slot, or yeah, anything else?
Okay. Alex, like, take as much time as we need. This is the primary deliverable of the working group. So if there's something,
yeah, well, security is not implemented on 802.11 OCB. Okay, I'm not aware of any deployment that secures these messages. Now, is that a problem? For me, it is a huge problem. Is it easy to solve?
Like, I would
Not so
suggest
easy.
like just putting.
Is it easy to write
Like, so, but
specifications?
put it in the security consideration, say what's being done, what's not being done, and how are people mitigating the stuff, right? Because at some point you're going to have to put it, because like once the security AD puts in a discuss, we're going to have to write it too. So if
People mitigate this by saying this is 5.9
Right.
gigahertz, nobody knows it. But
Right.
actually, people know
And
it.
like, if you do
That's what they
foresee this
mitigate.
issue, like, start putting some text in, and because like we see in like a lot of routing protocols, like, say like, hey, we don't need security, like, because we know the domains, like that didn't cut it, right? Like, so there's a lot of documents stuck in the IESG, like, until like these kind of things get done.
We I think yes, we hugely need the security, but we are not at a point where people are realize this need, because people have not yet started to buy these talking cars, and they have not yet seen these roadside units. Once they realize there is attacks possible, then security will come in place, and probably the easiest tool that will come is VPN. And VPN is not very well adapted for V2V. And
okay, thanks.
Yeah.
Dorothy Stanley, to address the security topic. So my understanding is that IEEE 1609, together with an ETSI equivalent, and I see William White is on the MEDECO, who have been, that he's been involved in getting a common certificate infrastructure defined across both ETSI and in 1609. So the security for all of these frames is handled at upper layers, and there are definitions for it. So I think a reference to those organizations and the work that they've done is one way to approach this. Secondly, I'd like to reassure you, okay, you are doing great work. All right.
Thank you.
I know it's not easy. It's not easy to stand up there and take the arrows from everybody who's, bringing that to you. It's the process. It's not personal. Okay. You are doing great work. You are the one up here doing this work of all the people on the planet, okay, that are standing up here. So don't be discouraged, right?
Thank you.
And you will have a great product when you're done.
Wait a minute. We have William before you in the queue.
Oh, is it okay? Sure.
Yeah. Hi. Yeah. I just wanted to echo what Dorothy just said. The approach that's being taken has been to apply security at higher layers. Yeah. I don't think it's fair. I really don't think it's fair to say that this hasn't been deployed. There are talking cars out there. There's a VW deployment coming this year where they're going to have up to 5 million cars equipped with this technology. And yes, there is security, but by and large, it's applied at the application layer or at the network layer. It's not applied to the IP layer.
Well, great. I'm eager to see this. What I'm seeing now is I see roadside units deployed. I see some talking cars, and they are not secured.
Russ, you want me to go,
This is
or
what I
is
see.
like there's somebody at the physical mic? I heard Sri, so I don't know if he's like. Okay, go for it.
Yeah, we're gonna have Shri, then Shirash.
So yeah, in the context of this document, I'm just wondering, is it already talking about the link layer security or like some application layer WSMP, some higher level, some application layer security, or what exactly is in this? Do we need to focus here? So that's not clear to me. Is it ND security? Which layer or which product?
Yeah. So William, I would greatly appreciate it if you can
Shirash.
like send us a note to like some kind of pointers. Like I don't mind if it's solved at the application layer. I just want like something to say like, hey, we are expecting this to be solved at the application layer, and that's how it's going to deal with this kind of network kind of threats, right? So we still like that doesn't absolve us from doing the threat model for this and showing how we're going to solve it. So if it's done at a different layer, all we need is a statement saying, hey, this is how we expect to address this, and this is how it's going to take care of it. That's all we need, right? So the thing is, the only thing that's not going to work is to say, hey, we're not going to do anything. It's different from saying, hey, I'm going to handle this at a different layer. So I think like Michelle was like putting in some of the stuff for the CAM message stuff in there. So I think it could be what we need to do is like document, like, what are the threats and how we propose to handle them. That's like really what we need to do, not exactly do everything again in this layer.
Yeah, Suresh, I'm not quite sure, Suresh. I think in the context of this, we are just talking about transmission of IPv6 frames, right? So unless we bring in ND or other things, the security, the threat model can be totally changed, based on, what we bring into this context. So I don't know if you should go, too much into that, but, just leave it at the point where say there's 16.2 security, then there's obviously ND, ND-based security, and just loosely refer to different documents, and that's about it. That's what my recommendation would be.
Yeah, so within ETSI, there's been a number of documents developed and published, and the nice thing about ETSI standards is that by and large they're available for free. So there's a TVRA, threat, vulnerability, and risk assessment that was done for the ITS setting. And if you just Google ETSI ITS TVRA, I forget the number of that document, but if you just Google that, you'll be able to find it. And then throughout the working group 1, the working group 5 in ETSI TCITS, there have been a number of publications about security. There isn't kind of one single document that summarizes all of it. It's a standard, so there's a standards organization, so there's a number of different standards that address different settings. But the threat model and the security model are fairly clearly laid out in all of those ETSI documents. And as I say, they're publicly available and free. I mean, it's also true, Sri, that there's no consideration given to IP security, and it would be worthwhile perhaps for this group, sorry about my dog, it'd be worthwhile for this group to do a security analysis, a threat analysis, specifically of the IP part, the routing part, and see if doing it in this setting requires any additional security considerations. That's something that hasn't really been done in that. So there's been a bit of security analysis of the geo-networking protocol, but not a lot of IP itself.
Okay, we're going to go to Tony, then Suresh.
Hi, Tony Lee, former implementer, and I don't mean to sound like the dog, but I'm going to whine about security. So this is a radio, okay? Anybody can send to you, so there's not much we could do about that. The link layer security has to be referenced, and it's not our job, okay? That's very much out of scope, and we should say that, and we should point to what we want people to use for the link layer security. And I don't actually know what the right answer is. At the network layer, this is an IP network. We got nothing, okay? We still have no decent security at the IP layer in any of our implementations. So there's not much we can say. And above that, it's just application security. And that's a well-known thing.
Yeah, it makes sense, Tony. That's exactly what I was suggesting. Like put in the link layer security and like application security. That's it. And probably throw in a reference to send just to like roll up the thing. Like even though we know there's not much implementation of this, right? So that's kind of what we did for ND, saying like, hey, like if you think like we'll protect against like rogue neighbor discovery messages, like put in some references to send and probably RA guard or something like that, and then move on, right? But it's like, just don't leave it empty. Like just like talk about the threats and whether or not we handle them. That's it.
Okay. Yeah.
Thank you. Alex, you may want to look at the Jabber log. There's a couple documents pointed to in there that you should just be able to add references. Thanks.
Hello, this is Paul Zhang. I'm an editor of this document, IPWAVE problem statement and use cases. Last December, Charlie Perkins and late January, early February, Gunda Bali gave the value of comment. We addressed the, I tried to order his comment, their comment. And also, I clarify key work items for our problem statement, such as neighbor discovery and mobility management and security and privacy. So major updates are, the first one is a reflection of Charlie and the trees comment, very useful comment. And also, I tried to add the gap analysis for existing protocols. I summarize the existing protocol along with their pros and cons, and also try to say some requirement for further step. The third one is the link model for vehicular network architecture. So I clarify that one. Lastly, problem statement case, especially vehicular neighbor discovery and the mobility management text I improved. This is the vehicular architecture. So you can see multiple radio can be combined using the shared prefix. We try to minimize the overhead of address configuration along the vehicle travel, along its navigation path. But it going to some other prefix domain, definitely it configure another prefix for its IP address. So linker model we discussed before, right? So we consider radio model, and also we can extend the traditional classical neighbor discovery with vehicular link model. The important thing is we need to provide simultaneously V2I and V2B together with the external interface with the single global IP address. Also, I addressed the adding node marks comments. We take advantage of lightweight DAD, such as multi-hop DAD, to minimize configuration overhead for DAD. We use the unicasted array rather than multicast array. And also, the one thing is that the neighbor discovery protocol also can be used for routing purpose. So if we are learning additional routing, so the routing overhead also added. So maybe we can take advantage of neighbor discovery for routing purpose. So this is the example vehicle, the neighbor discovery. So the vehicle can configure using RSU and mobile anchor. So the Chris Shen, he will implemented this. Also, we hackathon, right? So he will explain later his presentation. So I skip it. And the mobility management case, we have two requirements. The first one is a seamless connectivity during vehicle movement. The second one is a timely data exchange between two end host, or one end host and server. So based on this requirement, we have two principles. The first one is proactive mobility management. Second one is network-based mobility management. So let me explain one by at a time. The first one is proactive. We can take advantage of mobility information, such as the speed, the direction, and the position, and the trajectory. Trajectory means navigation path, because the vehicle, especially autonomous vehicle, it equipped with a navigator, right, with the GPS receiver. With this information, we can perform proactive the handover, which means the vehicle moving around, and it can handover operation can be done in advance. That is a very important feature. The second one is network-based. So network doesn't care, right? So it's a location. So network infrastructure take care of that attachment. So DAD, routing, and the handover can be performed by a network infrastructure. One example is a vehicle IP address configuration can be done the multi-hop DAD and the unicast array. So this is the one proposed. So in the end of this the session, if there is a time, I will explain this one. But the important message is we can using the current DMM working groups work. Probably a little some extension required, but yeah, we can take advantage of their work. So the first one is proxy-based, mobile IP-based handover, and also DMM-based handover. So next step is, I believe this PS document, the shape is looks good, I believe. So we want to lab up this problem statement document at this time, and the working group let's go. And then once we publish RFC, we can start discussion for the chattering. Thank you.
Thank you, Paul. So 2 comments, or well, one is that we need to ask Sri and Charlie to take a look at the latest version and see if the comments you posted have been addressed or not. So we need that kind of feedback from you guys. So Sri.
Yeah, Shri, I didn't get a chance to look at the latest. I believe it was posted just before the IETF, right? So I think in general, I think my only request is don't go too aggressive into solution space. If you can please leave it at the problem state. This is the problem, state the problem. That's it, right? Okay. Don't have an I think the problem initially in the initial versions, what I found, there was an architecture and it's getting reflected all over that thing, and specific solution. So that is that's where I think if you can fix that, make sure, I think we'll be in a good shape.
Yeah. Okay.
Okay, thank you. And then I have a request for you guys. So the review from Sri was posted on beginning of February, and then you posted the revision after the cutoff of the IETF. So if you really guys want to have this work progress, you cannot wait until that late, because this is gonna delay at least one iteration and I hope that the next revision after we posted the comments is not arriving before IETF, and of course not late after the cutoff.
Okay, I will put the high priority on this revision. Okay, thank you. Keep in mind. Thank you. So. Okay.
Okay, good morning. So this is Chris from SKKU. So I'm gonna present this IPv6 enable discovery for IP-based vehicle networks. So for this draft, I need to declare that there's a patent process related to this draft. So based on the requirement from the university. Yeah. So as Paul presented, so this work is based on the IPWave PS document. So this is a possible solution for the enable discovery in vehicular environment. And the topics in this draft include the following: the definition of link model. In this draft, we defined a new link model, which may be similar to the 6LoWPAN. And also we have defined an ND optimization process. For the third, is the proactive handover with enable discovery process in mobility management. So this subject is taken out already to a new draft. So the third one is MAC address pseudonym handle with VND. Okay, as many of you already noticed that this architecture. So we have defined this subnet. So all vehicles will share this shared prefix. So they will configure the IP address based on this shared prefix. So then when the vehicle move to a range of an RSU, so the RSU can be considered as a router. So the vehicle can configure its IP address based on the enable discovery process. Yeah. So yeah, based on this IP address registration process, it can avoid so-called multicast stone problem, because due to the energy and wireless channel conservation. Because if we consider in the future the electrical vehicles moving on will dominate the market, so the energy issue need to also be considered. So another is that so through this infrastructure-based address registration, so vehicles information need to be registered in serving ISU, yeah, for the efficient mobility management. And for the
So one question on the previous slide, this Shri. So the where you talked about the pseudonym, that was, yeah.
This one?
Yeah, I think so. Yeah, this is maybe to others as well, not just you, the presenter, but even to William. Or so if you replace the, you're rotating the max, as I understand, but will there be a stable pseudonym that will always be present in the packets? That's not. It's not clear to me.
Yeah, I agree. Yeah.
Maybe William is jumping in. Yeah.
So actually, so there could we need to figure out maybe some pseudonym operation. Yeah,
yeah, I think we can ask William to. Yeah. Okay.
Yeah, and again, this is something that is made complicated by the fact that in general people have thought about securing more at the application layer than down at the lower layers. But in the US system, because all security is applied to the application layer, it isn't even just that there's a single pseudonym that you use for a particular period of time. Different applications might use different pseudonyms, and if those applications are operating at the same time, you might have different pseudonyms operating at the same time. So there are still open questions there about the interaction between pseudonyms and MAC addresses. In the ETSI system, you have more of a coupling between the transport layer and the application because packets are signed at the application layer. And so it seems more likely that in the ETSI system, even if you're running multiple applications, that you'll just have one pseudonym operating at a given time. But it's still the case that pseudonym will change fairly frequently. The guidance is currently once every 5 minutes. And that when the pseudonym changes, all the other identifiers change as well. And so you'll need to redo neighbor discovery, or you'll need some mechanism to reconnect to a device after it's changed pseudonym.
Right. Yeah, thanks, William. That explains, but I guess that also introduces a bunch of problems, right? In the sense that if you're rotating the MAC and if you're also rotating the pseudonym, then I think the solutions that you're looking at, none of them will work, actually, or at least some of them will not work. So
yeah, noted. Yeah. Thank you. So, okay. So we also propose or suggest multi-hop duplicate address detection. So with this multi-hop duplication address detection, as we can see from here, a vehicle can configure its IP address and can make sure this IP address is unique through other vehicles through the V2V communication. So this operation can extend the communications, can extend the communication ability of a vehicle, which is not in the range of ISU. So yeah, so then in detail, so the MA mobility anchor need to maintain the neighbor cache and DID table. So the mobility anchor should be in charge of this DID process, which means a vehicle's IP address should be sent to the MA to check if this is unique or not. Then, so yeah, based on this vehicular neighbor discovery process, actually the prefix discovery is the basic process. And then in this neighbor discovery process, we also suggest a service discovery. So if you imagine that in the future, autonomous vehicles moving on the highway, and so probably each vehicle can has their some specific service. So if they can share these services based on this ND process, that would be something new and something good, yeah, to improve the service and the performance. Yeah. So as it stated here, a client in an internal network can also connect to a server in a remote, in another internal network, which it means it's in another vehicle. So here are the major updates from the previous version. So we updated on shared prefix model, and for the IP address configuration, and we also included the cancellation of enable unreachable detection in the design goals. Yeah. So in section 5.1, the vehicular network architecture is also updated based on this. We consider several subnet divisions and through the V2V communication. In section 7, so we also added a new scenario to cover vehicles which is not in the coverage of ISUs, based on the address registration and the multi-hop DAD via a relay vehicle. Here also in section 8, we just originally we put mobility a basic mobility management process. Now we kind of move this out as a independent draft. So as Paul already proposed, that this is how actually it's implemented in our the Hexon project. As you can see here, vehicle 2 can send the address registration to ISU, then ISU send this address registration message to the MA. So MA maintains the DAD table, so it checks if this address is unique or not. So it is DAD passed, then create an ACE in this mobility encode, then feedback the DAD result, confirm that your IP address is unique. So then, so this is for the multi-hop DAD case. So as you can see here, a vehicle which is configured as an IP address now, but it's out of the range of an RSU, so it can send the address registration through a relay vehicle. Then the relay vehicle will forward this DAD message to an RSU, then RSU forward this to the MA. So MA, so the similar process go back to confirm this IP address is unique. Then, so as I heard from the chairs, so because due to the current problem statement, so before the current problem statement document finished, so this working group will not receive any working group adoption call. So here we just put here. So we suggest to adopt this document as a working group document. And also in this Hexon project, we have implemented the basic concept of this operation. So hopefully in the future, we will extend it more and based on comments and the discussion with you guys. Thank you.
Thank you. Yes. Yeah. Just to clarify, as we mentioned, we cannot adopt any document as working group at this point because we are not chartered to do any additional work. So we first need to finish what we have, and then there will be a discussion to see whether we go for something else or we close. So just to clarify that point. Okay. Thank you.
Yeah, thank you.
Eric, not Mark. I was going to make a comment on the direction of this draft. You started to reuse some of the things that have already been defined out of 6LO and whatever, but I think that you're doing more and more of that, slightly different terminology, the use cases are different. But the fact that you have a mobility anchor point, to me, looks basically exactly the same as what's called a backbone router in the 6LO document. So I think that you can actually restate this thing saying, look, here's actually applicability of that, how you actually apply it to this vehicular environment. And there's additional things, like if you have these cases when you want to forward things to neighboring vehicles, whatever type thing, right? but then you don't necessarily have to do new protocol elements as part of this, or at least it will be more clear what is actually missing, what needs to be added specifically for this case. I would actually suggest that you go look carefully at the backbone router document and the associated one. So
Yeah, thank you. Yeah, I agree. Yeah.
Sure, I think in general, I think the document is assuming a lot of things. It's
Yes.
not clear to me. So I think, in my opinion, I think we need to have proper analysis and we need to step back a bit. I think, right. So this is good. I think whatever you're exploring, but I think when it comes to the actual adoption, there will be other proposals. I think maybe this may be based on 6 law, or maybe it's based on something else, right?
Yeah.
But at least I plan to publish other specs. So adoption at this time may be premature.
Yeah.
Alex Petrescu, I'm not sure there is some time for some technical aspects. Yeah. So on slide 7 and 8, please. Slide 7. Slide 7.
Yes.
Okay. On this slide, we see a vehicle performing address registration request that is further relayed by a roadside unit as a start multi-hop DAD towards a mobility anchor. And then the mobility anchor confirms or infirms, probably, if the address already exists. Do you know that in vehicle V2, there is not just one address, but there are many PCs in a vehicle?
Yeah.
Each one would have its own IP address.
Yeah.
Are we going to see many address registration requests for each of the address in the vehicle, or?
Yeah, I think that should be done.
That should be done. Okay.
Yeah, because I mean, we consider is each vehicle should configure a global IP address, V6 address.
Only one or several?
Sorry?
Only one address or several addresses?
One address, only one.
Okay,
Yeah.
probably, yeah.
From the mobility anchor.
Yeah. So yeah, actually, so at the end of our session, I will explain the mobility management. So it's going to different prefix domain. It configure another global IP address until the session previous prefix address is over. They maintain. Yeah.
Okay, thank you for the explanation. So still on this slide, when we do this address registration request, is it what is going to happen to the existing DAD procedure, like neighbor advertisement? You know, the vehicle already has a existing DAD procedure. Is it going to be overcome? I mean, the priority will be to this address registration request to confirm DAD, or the priority will be to the normal DAD that is already running, is executing? Who will be priority?
Actually, this address registration request is based on the ND process. Actually, this is NS, and the NA. So this address registration is in the neighbor discovery process based on the ND
Okay.
message. Yeah. Not,
Okay.
Yeah, not kind of we separate the new message. Yeah. Not.
Yeah. So I have some the complementary comments. So our proposal one is we can override once the beaker recognize this is on the road, right? So if we perform legacy neighbor discovery and this discovery case mess up, so yeah, we need to select.
Okay. And then on, I wanted to.
William's turn.
William. Yeah.
Yeah, sorry, I just wanted to note that I'm not sure that it's going to be realistic to only have one IP address per vehicle. I mean, it seems natural to me from a privacy and security point of view to look at different applications running on the vehicle, each running in their own virtual machine with their own stack, to provide proper separation, and so it's not to reveal to an eavesdropper that you're running this particular combination of applications. And so I would feel more comfortable if the system was designed to work with more than one IP address per vehicle.
Noted.
So while we are on this topic, this is Shri again, sorry. How about the ingress prefixes? So we are talking about the addresses that are configured on the egress or the OCB interface. But
Yep.
how about the prefixes that are given to the vehicle? Will they be from the same mobility anchor in your mind, in your whatever you guys are thinking, or will it be somewhere else?
So it depends on the coverage of this mobility and domain of this mobility anchor. So for a certain, like, if we consider Prague a city, so a district or a west district of the city can be managed by this mobility anchor. When a vehicle moves to another mobility anchor domain, it need to actually there are some more operations related to this process. There could be some optimization.
Yeah, that's fine. But my question is, will there be a topological relation between the addresses that are given for the inside networks and the egress address? I think that's what I'm trying to get to.
Yeah. Currently in here we didn't consider the internal network, so we just consider it just has a interface, outside interface. So internal network, probably we need to consider more.
Yeah. So in the absence of that, this would be incomplete in my opinion. But my follow-up question is, I think the question on addresses, multiple addresses, with Alex and William, I agree. You cannot assume that for today's times, a single address will be, that doesn't make sense. In fact, in all the mobile architectures, we have been arguing that a UE should be given a prefix, right? Suddenly, when we come to vehicular architecture, why that assumption should not hold? I think that's also the question. So maybe, is it because egress we give a shared prefix, and whereas ingress we give multiple prefixes is also the question. Or in fact, it's not in the prefix here. We are talking about the address for the egress interface. So all of those considerations are missing in this discussion.
Yeah, noted. Yeah.
Okay, we need to cut the line. So after Tony, because we're already over on time on this topic.
Hi, Tony Lee, Routing Geek. So this all goes to how IP works and IP addressing. If the thing in the vehicle is changing addresses all the time, all of your clients are going to be really unhappy. If your addresses are going to be natted, then it makes sense inside the vehicle to use private address space. And yes, I said private address space for V6. And I realize that some of you consider that heresy. It's still the right thing to do.
Okay.
If you don't have that private address space, all of your clients are going to change every time your car drives another block, because you're going to change your mobility anchor, you're going to change your prefix that you get down, you're going to change all of your addresses in your car, you're going to break all of your connections. We do not have mobility in V6 today. Okay? If you want to go argue about that, let's talk about ILNP offline. So the simple thing to do is to just get a local vehicle address and you're done.
Okay, so
no, we're cutting this topic.
Okay.
So please take this to the mail list.
Okay. Should I answer this question or no?
Yes, I'm just
okay. Okay, so based on what you just mentioned, actually those it's related to mobility management issues. So actually there are many standard RFCs related to the mobility management process. Yeah, as also it's stated in the ethics draft, right? So also we can utilize the PMIP, proxy mobile IP, and the DMM. So there would be multiple ways to do this. Yeah, thank you.
Thank you. Fred, you're up next.
Hi, I'm Fred Templin. I'm from Boeing, and I want to say that I'm very proud to be working for Boeing, and I want to say that also, thank you. Our leaders have made statements in the press, and I think the statements made in the press reflect what we all feel as Boeing employees. And for myself as an individual, not speaking as a Boeing employee, very saddened about things that have happened. and we're committed to making things right in the future. So with that in mind, I just wanted to talk about what we're seeing in terms of urban air mobility implications for intelligent transportation systems. So urban air mobility concerns the introduction of manned and unmanned aircraft within urban environments. NASA has initiated what they call the Urban Air Mobility Grand Challenge, and they're seeking industry participation. So there's a URL there that you can go to see about this. So what we anticipate is a future introduction of low altitude aircraft within urban environments operating in harmony with ground transportation. So autonomy and communications. As for intelligent transportation systems, the key enablers from urban air mobility are autonomy and communications. But there's a fine balance between the advancement of autonomy and public safety and acceptance, so industry and regulators need to work together. Vehicle-to-vehicle and vehicle-to-infrastructure communications become more important as personal air vehicles and unmanned air systems begin to enter the urban landscape. And we see the urban mobility landscape evolving from a 2D to a 3D coordinated environment with safety as the first priority. A common situational awareness picture. Personal air vehicles will employ vertical takeoff and landing and operate at low altitudes. And so deconflicting both terrestrial and airborne congestion becomes a 3D consideration. And that means that urban air vehicles should employ vehicle-to-vehicle and vehicle-to-infrastructure communications using wireless networking gear such as DSRC, C-V2X, et cetera. The same as for terrestrial vehicles that we're talking about in this working group. Again, an emphasis on safety. Public safety and confidence are the first priority. Autonomy in the urban environment is a certainty, but how we get there safely is the challenge for industry and regulators. So planning now for the future of urban mobility landscape, we need to look at scaling in terms of the numbers of vehicles in 3 dimensions, scaling in terms of communications, navigation, and surveillance capabilities, and safe separations and situation awareness for all autonomous vehicle classes. I think that's all I have. Was that the last chart?
Questions for Fred? And basically, I hear this as a call for action.
This is for SKKU. I think the urban mobility case also the very important issue, but probably the touching case we can discuss it. We can accommodate this kind of the urban the air mobility should be covered our working group or not. Yeah, so that's good. Thanks.
Good afternoon, Saulo, International Civil Aviation Organization. Fred, just one clarification. In your document, you define the urban air mobility below 400 feet, and you consider only 3D. And we know that to integrate these vehicles in the airspace, you're going to have to sometimes fly above that altitude.
Yeah.
And we are moving towards 4D. Why you are considering only 3D?
Actually, that's a very good point, Solomon. I think I should talk to you offline. We can modify the draft to speak to that.
Hi, this is Alexander Petrescu. I have at this level of detail, I have also at the same level of question. You are talking about a consideration of existing ITS standards that automobiles already use, and that would be used probably in the future also by other objects like flying automobiles or something like that. Now, in this space, there are some continent distinction at this time. For example, there is BSM messages in America and CAM message in Europe, okay? They are different, non-interoperable, and probably they will never interoperate. Worse, at SAE International, which is an SDO, defines a set of levels of automatization, level 1, level 2, level 3, level 4, and so on. And it only talks about speed like miles per hour, never about kilometer per hour. So, are we going to see the same distinction reflected also into flying automobiles? No, or no? Hopefully not.
Yeah, I think that's actually one of the results that's going to come from the Urban Air Mobility Grand Challenge program. So stay tuned.
Fred, Deshri. Fred, no, I agree with you. I think there's a good promise statement, but do you plan to bring some work into this working group, or I'm trying to see, how this can be translated into some technical requirements?
I think I really haven't gotten to that level of consideration yet, Sri. I think there's definitely some potential for technologies. For example, for civil aviation, and this goes to Salo's point, where we're talking now about 4D when we have, ground, air, and time, and all that comes into a 4D space. Do we want to talk about civil aviation within this group, or would it be a parallel group? I don't think we're at the point of proposing anything yet, though.
Right. Yeah, personally, I'm pretty, this group has, we can do some good work here. I hope we are stuck here with this OCB work, but I really hope we'll go beyond that.
Okay.
Eric Nordmark. So are there already other STOs that are working in this space? I'm sure that for regular, aircraft, right? There's STOs that standardize communication, but are there ones that are looking at sort of what's the split between, yes, we have terrestrial vehicles, we have regular aircraft, we have the space in between. Is that popping up elsewhere as well?
Where we're seeing the standards develop in other standards organizations, Salo was just speaking about International Civil Aviation Organization, and that's where a lot of the work gets started. But then there are other standards industries called RTCA and AIRINC. RTCA and AIRINC are looking at what they call RPAS, Remotely Piloted Aircraft Systems, which is also the pathway to unmanned air systems. So RTCA, AEEC, AIRINC, and ICAO are other areas where aviation standards are beginning to emerge, but we want to bring those to the IETF and harmonize those with the IETF.
Yeah, I mean, if we could sort of understand the requirements from this space and how it relates to ITS, that might be a starting point.
Good point.
Thank you. Next is William, could you please get in the queue? Okay, your slides are up.
Great, thanks. I can see them. So this is a presentation about a modification to TLS to use cooperative ITS certificates. There's an internet draft that specifies this, and I've just put the link to that in the chat. Next slide, please. Fairly standard presentation structure. Next slide, please. So just to note this, in the CITS context, a new certificate format was defined in IEEE 16092 and ETSI TS 103097 to profile 16092, but we'll refer to them as CITS, Cooperative ITS, Cooperative Intelligent Transportation Systems certificates. And they're size optimized, and they are also really designed for an M2M setting in ad hoc networks where knowing the identity of the party you're talking to isn't a lot of use. What you really need to know is their permissions. So they're designed around permissions in the way that X509 certificates are designed around identity. Next slide, please. And there's going to be a lot of these CITS certificates out there. The plan is for vehicles that participate in CITS to be provisioned with 609.2 certificates. And although 609.2 was CITS certificates were originally designed for individual message communication, so for sending CAMs or basic safety messages, signing the individual message. Once you've been provisioned with these certs, it's natural to look at, is it possible to also use them for secure sessions such as TLS provides? Next slide, please. So here's some use cases for sessions. And For all of these use cases, we have existing customers, we have standards organizations or ongoing deployments that would make use of them. So SAE, Society for Automotive Engineers, J2945/3 is defining a mechanism that allows vehicles to report local weather conditions to a center. That makes sense to do over a secure session. Vehicle diagnostics, being able to bring a walk-in device, connect it to a vehicle securely, prove that you're an approved diagnostic device run by an approved diagnostic technician, get diagnostic information from the vehicle. That's something that ISO 21177 is trying to enable. That would use secure sessions. Fleet management, very similar, carry-in devices. You want to have a persistent, secure connection. Electric vehicle charging, it's important to understand the capacity of the vehicle, the charging capacity of the vehicle, the level of the charge. There's real public safety issues around electric vehicle charging, and so you want that communication between the vehicle and the charging service to be authenticated. Again, that's a secure session. And just if you're looking at taking existing infrastructure and making it intelligent, if you're looking at taking a traffic signal controller and attaching an RSU to it, so that RSU can send signal phase and timing messages, SPATs, or related messages to let people make mobility decisions. Again, there isn't an off-the-shelf mechanism for doing that. Having a secure session mechanism would make a big difference, a standardized secure session mechanism. Next slide, please. And so the natural way to do this is with TLS. TLS is the best supported, best studied of all the secure session protocols out there. TLS 1.3, which was just published last year, is a significant improvement on TLS 1.3 in terms of both security and efficiency. And it's got a natural extension mechanism that allows you to define a new certificate type. And so the intent is to use that certificate type field to add this CITS certificate type. Next slide, please. And so there's a lot to say on this slide. In TLS, you have a handshake. The client sends its certificate, the server sends its certificate, or the server sends its certificate first. But both the client and the server can say what certificate type they're expecting to see. And so in this case, it would send a certificate type, certificate of type 609.2 certificate. Next slide, please. There's one additional change that we're looking to make to the TLS state machine, for want of a better word. In standard TLS, when you're proving possession of your certificate, you either the server or the client, you sign essentially a hash of all of the handshake messages to date. And what you output from that is a raw signature. So in the case of elliptic curve, that's a 64-byte opaque blob. For 609.2 certificates, part of the permissions model of 609.2 is that whenever you sign something, you create a 609.2 signed data that says, this is exactly what I've signed, not just here's the data, but here's the application domain that it's relevant for, and so on and so on. So that on verification, you can check that, yes, this certificate was entitled to sign messages in this application domain. And so to be consistent with that 609.2 philosophy, rather than having this certificate verify with 609.2 certs be a raw signature, the intent is to make it a 609.2 signed data that contains the signature, but also contains all of the other metadata that 609.2 implementations expect to see. So what that means is that your TLS implementation needs to be modified, not just to know this certificate type means we send a different certificate, but it means this certificate type means that we invoke a different verification routine. From the point of view of software, it's still basically the same. You have an interface that takes in data and puts out signature, an interface that takes in data, a signature, and a certificate, and outputs the result of verification. It's just that inside that opaque blob that we're calling the signature, there's more structure in the 1609.2 case than there is in the standard TLS case. And we
I just want to, what you're really saying is, even if the cryptographic algorithm is the same underneath, you're wrapping it in this other structure, and so you just need an identifier for that algorithm, where that means the traditional algorithm with the extra wrapper.
Yeah.
Yep. Okay. Thank you.
And obviously that's a change to the TLS logic. And so that's something that needs to be discussed. We had a good discussion on and off the TLS list with Ilari Ilusvara. Sorry for not pronouncing the name cleanly. But we went back and forth with Larry to make sure that there weren't any concerns with it. And the outcome of that discussion was that so long as we only use this approach with TLS 1.3, he didn't have any security concerns, which is good, because I think these are going to be new deployments. We want to encourage people to use TLS 1.3, and so locking it down to TLS 1.3 seems like a good decision anyway. Next slide, please. And so obviously a natural place for this to be turned into an RFC would be in the TLS working group. So we presented it to the TLS working group, and we also presented the IPWAVE working group at the last IETF in Bangkok. The TLS working group wasn't interested in adopting it as a working group draft, I think just because there wasn't a lot of overlap in stakeholders. And the TLS working group is much more focused on kind of traditional internet settings. But they said, all you need to do for your purposes is go and get a code point and have a stable reference. So we got the code point for the certificate type, client hand server certificate type, that was issued by IANA back in November last year. And now what we need to do is get a stable referenceable draft. So as I noted earlier, there's an ISO standard that is actually quite close to being issued that needs to reference this specification. There's an SAE standard that again is quite close to being issued that needs to reference the ISO specification, which needs to reference this specification. So there's real kind of market demand for this to be finalized and stable. And so we're very interested in seeing what we can do to make that happen. Next slide, please. So in summary, these are certificates that are going to be widely used. They're going to be in all cars. They're the basis of all of the CITS deployments that are going on at the moment. We're seeing significant industry demand for support for secure sessions enabled by these CITS certificates. We've got a code point, we need a stable draft, and I understand that it needs to be chartered for this group, but given that TLS working group doesn't seem particularly interested in adopting this draft, and it would be good for this draft to go through the scrutiny that you get from having adoption from a working group, we'd be interested in having a discussion about what's necessary for this working group to adopt that draft and move it forward. And that's it. Last slide just says, thank you, any questions?
So as we have said about the other drafts, we need to complete the 2 work items before we can adopt anything new. But if anyone has any words of support or words of otherwise, please come to the mic.
So William Deshri, so is this document referenced in the 1609 documents as a normative reference, or what's the status there?
It's not referenced in, so the way the layers work is 1609.2 defines the basic mechanisms, then this document is TLS using 1609.2 certs, and then ISO 21177 references the TLS document. So ISO 21177 would have this document as a normative reference, 1609.2 wouldn't.
Okay. Yeah, so I think, it makes sense to review this here, I think, but yeah.
Okay, so I hear only so far words of support, but I have we are blocked until we finish the other two work items. Okay? All right. Thank you, William.
Thank you.
So basically the main idea is already presented. So I just address the intention of this draft. So the purpose of this draft is I am Jeon Porjung from SKKU. So we want to address what is the requirement and the principle of the design for mobility management. Yeah. So yeah, we explained this. So requirement is sharing of a prefix for multi-link subnet. Also, we are providing seamless handover, and also consider the handover between different prefix domains. So design principle is I said during my presentation, the PS document. The first one is the proactive mobility management, take advantage of mobility information. Second one is network-based mobility management. So restoration is Chris explained, and also we can take advantage of the proxy mobile IP. You can see the vehicle moving to from current the multi-link subnet, and it going to next. The multi-link subnet is the same. The RC different, the attachment is different. So we can take advantage of a proxy mobile IP to handle that. Also, we can optimize using DMM. Also, we consider multi-link subnet, which means two different prefix domains. Also, we can handle using proxy mobile IP and also DMM. So the once we finish the PS document, we can discuss this one. Also, we can prove concept. By the way, this one is I profile the IPR, so I will declare later on. Okay, thank you.
Yeah. I'm sorry, I was kind of multitasking there, but I've heard mentioned a couple times now multi-link subnets.
Mm-hmm.
There was a document by Dave Thaler on multi-link subnets. I don't know if you've seen this, an RFC that talks about the dangers of multi-link subnets. So there might be something to be learned there.
Say that again. So what is it?
RFC on multi-link subnets from Dave Thaler.
Dave Thaler. Okay,
yeah.
Okay.
Yeah. So I'll dig it up and send you a pointer.
Okay, sure. Thank you. Yeah. Maybe the concept, some part is the same, some part is a little different, so we can clarify. Okay. Thank you.
Thank you. So with this, we finished just 4 minutes before. So
okay. This approach. So Los and Carlos, may I suggest? So we already work for the PS document. Actually almost 2 years, right? So can we let's call 3 weeks, and then during that let's call I can get the comments, and then I can work with the other guys. No? So how?
You have to respond to the existing
comments first. Okay, good. Yeah.
in a timely manner, if I may add. Okay.
You get the certificate after finishing it.
Thank you very much.
Okay, thank you.
They'll be shutting the network down very shortly, so don't be surprised.
Hi, I don't want to bother. Okay, I have one short question about your presentation, the broadband statement. Okay, yeah. So the mobility management. So in many pictures, I saw the transition of the path from one subnet to another one. Right. So is there any kind of experience or take on how frequently cars should replace their IP address, or would it make sense to have IP address continuation for a larger space? So my interest is really how much we depend on IP address continuation. Because if you continue using the IP address, you could also mitigate the impact of this neighbor discovery.
So usually the DSRC wave communication range is maximum is 1 kilometer. And so in that case, you can see the urban area case, usually the block is less than 100 meters, something like that. So in that case, you consider maximum DSRC communication range, also the